Sure. Okay, welcome to the next Lava session. It's we're going to talk about refactoring the Lava dispatcher. And for those of you that are unfamiliar with this component, this essentially is the software layer that talks directly to the devices under test. We'll actually run the tests and create the test bundle that then pushes it to the server component. So we're going to kind of give an overview of why we think we need to rewrite the dispatcher or refactor it, and then kind of walk through the new designs. And what we want to do is make sure that everybody's use case is heard here in this forum and that we've considered it. So with that being said, I'm going to hand it over to Neil here, and he's going to talk a little bit about our agenda.
Okay, so we're going to cover why the changes are needed and also the flaws in the current working model. The main thing to think about here is that we are not worrying about backwards compatibility. This is a big change over the submission format that you're using is going to change, or the test definitions don't necessarily have to change, but you'll get a lot more out of the new refactoring if you take into account the way that the new design will work.
Can you explain how we're dealing with that compatibility rate?
Yeah, what we're doing is the code is going into master as the new model is being designed, but the existing model is just taking the current format and working as normal. What we're doing is we're using a YAML-based submission format, and that's only for developer testing at the moment. It's not anywhere near ready enough for actual submissions to come in through the UI or through other tools. It's working just on the actual dispatcher. We'll gradually bring that up, and then when we've got to a point where the new code is ready for more widespread submissions, then we'll start bringing it up and make it obvious through the UI. But at the moment, it's all being worked just on the command line on the dispatcher directly in the code base. So, like a lot of projects, we built the dispatcher organically over a long period of time. There were a lot of features that came in as hot fixes and temporary fixes, and they're still there. There's a lot of, for example, there are stages where the timeout is set for a particular board that has been long retired, but the timeout default is still in there. There's a little comment, but these kinds of things, these kinds of problems end up being a real nightmare when you're trying to add new boards or new ways of actually running the dispatcher. And huge amounts of duplication, entire class structures that actually should be the same thing but can't be yet. It's also difficult to actually test what we're doing. So working on the current dispatcher is, how would you describe it, Tyler? Painful?
It's like trying to juggle a bunch of broken glass bottles.
Yeah.
That's the only way I can describe it.
So we decided we were not going to do that anymore. So the refactoring is going to take time, and we're going to have to keep putting some changes into the existing dispatcher. But the focus is on getting a proper design and a simpler way of expanding it to a whole new range of devices and roles. And the current dispatcher, yeah, we've already had comments at the end of the last talk that the current dispatcher hinders actually identifying problems because you can't split up which boot log is this? Is this the master boot, the test image boot, the master image result boot? What we're actually doing as you go through. All these kinds of things will be addressed during the refactoring, and they've already been taken into account in the initial design.
I think it's important to note there is that we get used to it. We can dig through the master image boots and understand what's going on, but a lot of people from the outside look at those logs really have no idea why we're booting like 7 times in a job. So yeah, the goal is to be able to split that up so it's very clear what's happening and what part is actually the test image and what part is not the test image.
Yeah. We get used to it, but even we get confused half the time, so it's just as well we're actually fixing this. So that's the main part there of the current flaws. A lot of those will be familiar to anybody who's actually tried to actually debug a Lava test job in the past. Some of them are like the loop-back devices. That's proved to be a real headache for the Lava lab team at times. Timeout uncertainties, yeah. So many different places the actual value for the timeout of a particular action is specified. And special case code is everywhere.
Is there going to be a support for partial results? So the results run and the shell eventually times out, but we get to grab the results that we had so far.
So part of the, let's go on to the, right. So one of the principles of the new design is going to be that actions are self-contained. So if you're doing something, then the results of that action are bundled into that set of results. So you get the results as the job goes down. You don't wait until the entire job is finished and then try to parse the entire log. Right? You build your result set along the spine of the job as the job runs.
What my use case is, for example, that I'm running a job, a test, and produces a bunch of results, and then at some point kernel crashes and the shell eventually times out. So what would happen then? Do I lose the tests that were there, or is there a way to...
We're not at that stage yet, Milos, to actually work out exactly what's going to happen. It's still at the design stage, but the expectation will be, unless you get to a situation where the device media has been corrupted by whatever calamity happened, then we should be able to get that off up to the point of there. You'll still be, because it'll be the same principle as now with the actual log file. You'll get the results as far as the log file goes. If the log file just blows up and the device just goes away, well, you get the results to that point.
That's exactly the point. At the moment, you're losing everything that happened before.
So basically, like right now, we accumulate results at the end of the test run. Like everything completes, and then we go and look at the test, each and every test folder, and then accumulate the result at the end. Right now, it's not going to happen like that, because each and every step, each and every action is going to be incrementally accumulating results. So each action will have incremental results. So at least if something fails, at the end you will have at least say 50%, 60% of results which have been run incrementally.
So sorry Neil to keep butting in with questions, but my question is, if at the moment we write the results to the media, right? Yep. And then why do we not pull them back over the serial or whatever connectivity we've got as we're going through the job? And
so then that works if it can't retrieve off the media. We fall back to parsing just the raw log output.
But if we did that all the time, we wouldn't have any reliance on the crappy media.
Well, the serial output sometimes isn't always that good. So.
Yeah,
but we log the output to a file, which tends to not have as much problem. So we kind of use that as a fallback right now.
At the moment, the log output will be written to the SSHFS. It'll be written as the job log file. So yes, you may lose some artifacts that are actually on the physical device, but as long as you actually have a log file being available, you will be getting results up to that point, because the results are going into the same point as the log file all the time.
Okay, cool. Let me talk about that. So in your use case where you're running a test and the kernel crashes, what I'd like to see out of this is we are able to, A, get those results, the partial results list, mark that the test case was incomplete, right? But then also look for those kernel errors and put them in there and say, you know, there was some sort of platform issue. Here's what we detected on the Lava side as a potential issue. Not only that, but if we do a p-expect timeout, we don't just say p-expect timeout and it blows up and raises some weird error. It's, you know, platform stopped responding. So we're also looking to get better error messages back to the users on why their test didn't finish or things like that.
There's a problem with the slides, and sadly, that I haven't got the resolution worked out. There's a line at the bottom of this which is actually missing. If you want to switch over. Because what we're looking at with this is the actions will clean up after themselves as they go through. They'll have the ability to do retries. So you'll actually have the ability to not retry when it works, but if it fails, you can actually set in your submission, right, retry that 4 times if it fails. So that will be automatically built into that action.
So do you want to talk about kind of like the health idea that we had? Where
Well, I was just going to cover the other part on the slide once Tally gets back up. It covers what he was talking about in terms of picking up how the errors work, because you, as well as the actions being able to react to failure by retrying, they can also react by running diagnostics. So if you get a problem with an action that is meant to do something on the network, and that action comes back and says that didn't work, then you can actually run some if-config stuff and put some log output and work out, get some data about why that action failed. Then it'll actually we'll just get back to that slide.
So if I have to run this, would it even work if I just have to run the same test again and again, like 5 times? Without, even if it passes, I want to run it just 5 times? Does it be?
There's a separate support for expressing a retry on success. This is particularly looking at error identification and reliability side, that you can specify that if this particular action failed, you want to retry that action.
You're talking about the looping of this, and that is part of the Lava test shell effort. It'll be we are having plans to implement that, so soon it will be available. But this is specific to the action retries. So if something goes wrong, if the network has not come up, and we just don't say network is not there and then fail there.
Yeah, actions are more than just the actual test definition stuff. This is all the actions about the deployment, about the boot, about the actual, all the mechanisms, all the stages within that. So the individual downloads are individual actions, and they can be retried, and they can have error handling and diagnostics. It's handled through a pipeline, so we actually have a simple way of showing the pipeline, and when you are writing your submission, you can ask for a view of the pipeline. You can see all the actions that that particular set will generate, and then you can just follow it down to the simulation mode.
So what we kind of think about the health of a job, right? If we have to boot your kernel 3 times to get it to work on the platform, that should be a problem, right? That's, yes, you booted and you ran tests and some tests passed, but that's not good. That's not a good behavior. So essentially, like kind of what Jenkins does, where it has, like basically out of 100, every time we have to do a retry on something that is to work around the board or a piece of infrastructure, then we're going to decrement that number. So you may have a test job that fails or that passes and everything's fine, but you look and you have 56 out of 100, and that's not a very healthy job. And this, it'll tell you we had to retry the boot 3 times, we had to try the network 3 times to get it to come up. So we were able to run your tests for you, but we had to work around the hardware platform or the software that's running on top of the platform, so that somebody looks at the results and says, oh, that's not good, we need to fix that. So that's kind of another thing that we want to solve.
Yeah, there's a lot of tests at the moment where you get results because you're lucky, but you don't know that. And now this gives us the ability to actually say, this action, yes, it has a retry built in. It shouldn't have needed a retry, but that actually happened on that. This also ties in with making sure that we can identify the cause of the errors as well. The actions themselves become much more intelligent. They become, as is on the slide there, become idempotent. They can clean up and look after themselves. They understand the actual actions are small enough that they can pick out, right, is this a submission error? Is this a test error? Is this an infrastructure error? Or is this a Lava error where somewhere our code is wrong?
So like if we're using tar on the dispatcher and it blows up on us, that's going to be marked as an infrastructure error. Whereas if we're running a test and it stops responding to the serial line, then that's more or less a test image error. Yeah.
Does this also apply to like the host side? Like for example, Android CTS testing, whatever we talked about is actually running on the device, right?
Everything is an action. Every part of the job, every small part is an action.
So
whether it happens on the dispatcher, whether it happens on a device, whether it happens when the device is rebooting, when the device is working out where it gets this next test definition from, every individual step we're making the actions as small as we possibly can. So there's an action that does a particular download. That's one discrete action. And if we can reuse these things, because we're using a sort of component model all the way along, but each one is getting enough intelligence that it can handle its own problems and report them sensibly and its own results.
Yeah, so in the case of Android, right, we have a base class called action, and then maybe ADB action inherits from the base class action. And this action class has predefined methods. One's a run method, one's it's the pre-deploy.
Yeah, you've got pre-process, you've got run, and you've got a cleanup. At the moment, the actual code implementation of this has only got as far as booting a KVM on an x86. So there's a lot of work going into this for how these actions actually work out at the end. So we'll do one now. So we've got, so stimulation is really important. It allows you to have a breakdown of the entire job, and you can see exactly what actions happen. The pipeline is done through a second. You can imagine it like a document with indentation. You've got a block with a nested block and a nested block and a nested block, then you come back out to the next block down. So 1.1, 1.11, 2, 2.1, 2.2. And you follow it all the way through from each one. And they'll show the parameters that action is using. They'll show the result of each of the. There should only be one command ideally in each action. So you'll have the result of that command. You'll have the standard out for that command. You'll have anything that actually happened as it went through. They'll describe. Each one will describe the timeout that applies to that action. It'll have whether it's a retry, and all this information will be carried through. Now, when that job finally gets to submission, all that data is retained. At the moment, we strip out a fair bit of information when we do the submission to the bundle. In this model, all of the data will go into the bundle. You've got a lot more information available to you to start putting through with reports or analysis or whatever you need to do, because you'll have all of the discrete blocks as you go through the job.
And where I see this being really useful to use is when you write your job definition, we're allowing for flexible deployment. That's one of our use cases where you can actually specify, I don't want to deploy this to the SD card. I'd like to deploy this to the flash, eMMC flash, or save to drive. And then each platform will be able to describe what they have available to them. So when you do the simulation, it's going to say, hey, you can't do this on this platform because it doesn't have this block device that you're requesting. Rather than today, when you submit a job like that, you have to get to the point where you actually try to use the block device before it explodes, and then you have to go digging through the logs to figure out why. Another use case is you want to understand how many times the platform is going to reboot, and is it going to reboot in between tests? Because we have a Lava test shell action now that kind of inherently says, yes, I'm going to reboot into the master image to pull the data off and then boot back into the test image. But it's not clear from looking at the JSON if you're a new user that that's actually going to happen, right? But at least running the simulation, you'd be able to see what's actually going to happen at each step. So hopefully we'll.
Onto the next
So
slide.
now there's an option of selecting not to reboot between tests?
It's not so much that there's an option to not reboot. You have to be explicit about when you go through a boot process. The new YAML will say if you just go into a test, then you may well get an error that it hasn't booted at all. But you have to say when you want the board to be booted.
Reboot is an action.
Yeah. And we'd like to have it that way, so that there's no hidden stuff that Lava's doing behind the scenes. It's explicit. Yes, it makes it more verbose, but I feel that being explicit with what it's doing and puts the user in control of the board a little bit more.
The other thing this allows us to do is, for example, support parameter overrides for particular actions. So if you need to change the arguments to one of the commands that we would actually be putting through, then you can discuss with Lava and say, well, which parameters can we allow to be overridden here? Because there obviously be security or safety problems with allowing certain ones to be overridden. But we can actually have ways in the YAML of the submission and saying, for this particular test job, I want to specify this parameter to QEMU so that it has more memory or it uses another core or whatever else like that. And those kinds of things will become more obvious because then when you do the simulation, you'll see the command that we're going to use before you do the submission. Can you go on to the next slide? So we've put a simple overflow of a flow diagram of how the dispatcher design is working. So we've got there the blocks. You can see how the job breaks down. So you've got a job comes down to a deployment. It's got a deploy action. Well, a deploy action consists of other actions. So you've got a download. Well, then you check some of the download. So that's a single action on its own. Then you've got the mount. Now, after writing this particular page, you find that actually mount has sub-actions as well. So that becomes that has its own little pipeline. There's lots of other things to work out how to mount, because you're dealing with different media, you're working with different file systems and all the rest of it. But you can see there that's the basic structure of the pipeline.
You're not going to have to define each one of these things, but like the deploy action you would, where you'd say, this is what I want to deploy, much like you do today. But the deploy action inherently has all of these sub-actions associated with it. So
in the YAML that you would sort of put down, you would just say that you want to deploy to something with this tarball or this image, and then when you do the simulation, you'll see how it's going to do that. So you don't decide these things as a test writer. This is how Lava is doing it under the hood, but it's making it transparent all the way through so that when you're looking at the logs, each of these actions has their own log output, and you can tally that back straight to the simulation. So you can look at the simulation and say, right, this is action 5.6.2. And you look at that particular part of the log, and it says, right, that's exactly what happened at that point.
So I threw up our sample job definition just to kind of give people an idea. And the nice thing about using YAML is you can comment. So it's not just this big hunk of JSON that you're like, well, what is this doing? What is this meant for? You can actually put comments in there. But this is kind of what we're thinking as the layout right now. So there's a deploy action, and there may be multiple deploy actions. So you may be able to say, I want to go first deploy this to a SATA drive, run some certain amount of tests, then maybe deploy it to another boot media at some other time.
Because with the deployments there, you're not necessarily deploying a kernel or something like that. You could be deploying data to the SATA drive and a kernel and a rootfs to the SD card, and then you boot it up with that particular configuration. Or you can flip it around the other way. So the important thing with this, when we actually get to the point of allowing these submissions to come in from everyone else other than just the developers, YAML still has a fair bit of syntax, and you're going to have to be careful, and we're going to have to be careful to write the submission checks that make sure that, for example, when you use a hyphen there, you do hyphen from : URL, that has strict meaning in YAML as to whether that's a list or that's what kind of data is going through. So just like at the moment we recommend people go to jsonlint.com and things and do that, there are online YAML parsers, and we'll be recommending that you put your submission YAML through those parsers, and there'll be a lot of work in the server to actually get these validation errors picked up at the earliest possible stage.
I have a question about one of the syntax used about test definition. We see that we can have from URL, from git, from file. Can we embed directly the test definition inside the job definition now, since everything is in YAML?
Oh, you mean actually put it inside of the job definition itself?
Yeah, just wondering.
I don't think that would be too much to support. I mean, it might not be.
It does make it harder to reuse that test definition in other jobs. It's nice at the moment that you've got the ability to put one job across.
I get the drawback, but sometimes you want to test before. Let's say I'm a developer, I'm writing my test definition, and I don't want to go through Git for that thing, and once I'm good, I can send it to QA guys.
I think that's the use case. It sounds like it's going to be useful for you guys.
Prototyping is very useful, but for now I can just create the YAML, push it to the Git, and then take it.
Yeah, and I know that pain. The main thing with that is, don't forget, you can also still put a version string in your YAML and then reference it with a file URL, and then just pull it in directly. You don't have to Git, but yes, it's something we can actually.
I see your guys' use case on that. I feel the same way when I'm developing tests. That it's nice to not check it in first.
Or in general, when someone wants to start using Lava, having just one YAML file to create instead of two is like makes it easier, more approachable.
For the very simple start-in jobs, yes, that's exactly the kind of thing that we could actually do.
Yeah, so going maybe too fast, I'm just wondering if there's any publishing API now, or publishing action.
I've been working through the whole publishing stuff for months. I think I've wrote an initial document on how we could do it before Macau, and there are still things to actually work through it. With the current dispatcher, it's just not feasible. But with the we can put in some kind of publication action and make that available. That's certainly something that is it's not something we can get to quickly in the dispatcher refactoring, but it can be added into that. This is the main focus of the refactoring, is that it's going to make it easier for people to come up and say, well, look, here I've written out a little bit of Python that adds new action. It inherits from download, and it does some weird extra stuff. And there's that little lump of file, and they come up with a review. It slots into the code, and you just call it as the pipeline goes down. So it becomes much easier to extend the actual Python code within the dispatcher to add new actions and to extend these things and to make them more useful, more detailed, and do unique stuff.
So I want to clarify the publishing request here. Now, do you want an action, or you want to be able to do it within Lava Test Shell, or both? And I guess if you want an action for it, can you describe the use case of what you might want to do with it?
So, well, maybe we can give a bit more details, but just my point of view on that is we don't necessarily need to push some results on the bundle. And I just want to put some HTML file, whatever I generate.
Okay, so
results
within the text or
somewhere,
like
yeah.
There would be like some action that says, go find this file on the file system and put it here. It would be within the test shell script, right? Or is there a use case where you'd actually want an action where you describe some file path on the test image that you'd want to publish somewhere?
We actually have a use case for doing
exactly.
that.
That's what I'm getting at. It says you need to support both.
It doesn't matter. It doesn't matter.
It doesn't matter where the file needs to go or how it's actually done. But Rémi and I have already been talking about, particularly with the publication ideas, is that, for example, you might actually want to dynamically generate the KVM image that you're going to use. So you might want to run VM to Bootstrap and actually create an image that's more up to date and then publish that file, or maybe even just use it in the next part of the test. So those kinds of things can happen, yeah.
So just in general, the need for publishing comes from the fact that everything from Lava goes to Postgres, and we don't want to bother you by putting two huge files there.
Exactly, yeah. Yeah, the current dispatcher is limited by exactly that problem of putting large files into the database, and it allows us that flexibility to get around those problems.
Basically, like we need to look at the stream submission action which we have right now to be modified to say something like publish action. So it could be a Lava stream, or it could be elsewhere. So
what I'm thinking of here is that it would be entirely separate from the result submission. It would be an action you could insert at any point during the test job that actually says, right, this previous action, if that worked, that will have caused this file to be created at this point, and the publication action says, put that there. and then it's just an action you can put into the pipeline, wherever it needs to be.
Yeah.
But the security is down to how that particular sub-action works. You can have an SCP action if you are able to provide a private key into the test image. All these things can actually be worked on from there, but it's a long way down the road as to how we actually do that.
I guess that's my question. So will there be something like secure deploy? So we have a use cases now to like deliver the firmware to the board, but we cannot publish the firmware, so make it available online, but we have to make it available to the device only.
Yeah.
So that's something we should consider. I don't know if we.
It's something that's in my
Okay.
plan for the yeah. Well, you're still going to log it. You don't actually display it. The important thing with the refactoring is that because each of the actions has its own little block of output and results, then we can also make sure that you only see the bits you're interested in. So you can go directly to a particular action. You can even, we're not sure yet whether to put this through as user profiles or something in the UI that says I don't ever want to see these actions or those sorts of things, or maybe do it based on whether you are a developer or what kind of user you are. Those kinds of things have yet to be worked out, but there will be ways to hide big blocks of the current log output based on who you are, what kind of view you want to see. Now, maybe you'll still have an unfold or a drop down that lets you see those, or maybe you hide them entirely. We have not decided yet. The main thing is to work through the actual dispatcher side and get this the data structures right at the dispatcher end, and then once we get those sent back to the server, then we can go through the whole thing of how it looks and how it's controlled and who sees what. But the main thing is to get the dispatcher generating discrete chunks of output and results and the actual command lines that did all that. So you get one complete block that has everything related to that one action.
Sorry for my ignorance of Java internal, but is the dispatcher related to how we handle the logs? So one issue that I have and reported that there's too much noise on the log.
Yes, this is exactly what we're looking at.
We want just to console.
Yeah,
So
that's exactly what we're looking at.
Each action is going to log, and see right now it's just this monolithic log. Everything gets logged in one place, but each action would do its own log, and so that when we put those on the server, the web front end can figure out what to display, and so we can say, I only want to see the test image boot by default, and then I can click on buttons to see, okay, well, I want to see the first master image boot, second master image boot, and so forth and so on. So then you can really isolate it down, and then being able to link that view to somebody. So when you figure out exactly the part that you want them to focus on, that you could then say, here's the link, and then when they go, that's all they see when they look at the log.
Now, the other part of that is that with the refactoring, every job will run in full debug log level. You do not have that option anymore. It will always put out all the information it can actually work out as it goes along. We've had too many problems where someone has run a job on info log level, then come back to Matt or Dave saying it failed, and Matt and Dave haven't got any actual information to work out why it failed. So now Lava will always run in debug, but you won't necessarily see it unless you choose to see it. But it'll always be there for those who actually need to help you fix the job afterwards without rerunning the job.
Debug by default, but not to the user. The user will still see just the info blocks. Yeah, but the problem is that if somebody doesn't submit a job with info level debug, then none of that.
I was submitting with info,
If you submit with info at the moment, then the debug output is not generated into the log file at all. Well, if it is, it's a sign that the old dispatcher is still proving problematic.
Debug, you mean to say, generally whenever there is a crash, in the case of crashes, we generally developer always asks for crash dump. So debug messages,
yeah.
I think it's not really crash dump. So are we even store? Do we really store crash dumps in case of a crash or something like that? So
Yeah, and I think this use case is the debug from the dispatcher. So the dispatcher saying, I'm running this shell command on the host side to prepare an image, having all of that, the exact call, the return code, things like that. I see what you're getting, the actual crash logs generated. We have a use case where we have a whitelist, blacklist, so where you can say, you define strings that are interesting, that are basically more or less crashes. So if you want to test for a regression in a test, you can put a strings and list and say, if you see any of these, please mark this in the test result. So kernel oops, cut here, those kind of things, where it would be reported in the bundle saying, hey, now these are warnings, right? These are crashes.
That becomes part of the intelligence of that particular action. The action understands what it's trying to do. We can put the code in there that says, right, this is a boot action, and if it finds these particular messages, then it'll log those as a test error or a job error or whatever else, actual warning that comes through from or is necessary for that kind of role. So it's generating all the data in the first place is the main part, and then how it actually gets shown and what bits you see is a secondary consideration. We get the data into the final submission first. Is how we're going.
I have another question. We are always talking about pass and fail. So how about wherever the manual interaction is required? For example, the system cannot decide if it is really pass or fail. It really needs some manual interaction to see if it is pass or fail. So there, I think we need to dump some of the information, but it doesn't really pass or fail. It says something like post-process kind of stuff. Is that?
I think you're thinking of the parser, the actual test result parser that comes through.
But also manual intervention.
Yeah, being able to then post-process. So like if you run a test, like the open embedded, the Octo test right now, the P test, where it's really hard to write a parser to get every case, right? But then being able to go back, review the log, and then enter in the data manually. This test case is the name, and it has to fail. Is that what you're getting at? Yeah, so more or less being able to automate the deployment and run the test, but if it's too complex to deal with in an automated fashion, having the ability to go then back to the bundle and insert the data, saying this passed, and here's a link to the log file where I'm getting that information. I think that's what it's getting at.
Today we allow the ability to comment. We don't allow the ability to modify the test.
Yeah. Modifying the data that goes into the bundle is actually a risky thing to think about. We need to go through that.
Yeah. So make sure that's written down, and we'll investigate that and see if that's feasible. Thank you.
Sorry, I have one more. Sorry. Actually, engineers as a developers generally they have lot of duplicate code, and also most of the error conditions have not been coded properly or reviewed properly, whatever. So is there a possibility of finding the complete code coverage kind of stuff where you can say this part is never run in his lifetime by the
inside the test? Where you run the coverage? Are you thinking the coverage of our source code or the coverage within the test?
Not developer code.
Sorry?
Developer.
Yeah.
If I understand it correctly, correct me if I'm wrong. You have basically a test case, right? And it basically wants to check how much of test coverage in my kernel did I get, right? I mean, and if you have like set of 100 tests, right? Like, how much coverage am I getting? Like in the MMC domain or USB domain or whatever.
I think that's out of scope of Lava.
That's basically it's completely out of the scope of Lava because the tests are different than the Lava infrastructure as such.
Yeah, that really should be done as a test plan prior to it. So you identify, if I run these tests, this is the coverage that I get. Lava really doesn't dictate how the tests run. It just simply runs it and then parses the standard out to generate the test results.
Lava doesn't know about the coverage of the code which the test does, but you can run the tests under gcov and then you get the results. We have been recently testing that on Lava, how to use gcov to see what lines of the kernel are being tested when you run the LTP test suite. So it's certainly possible.
Yeah, but that's not a feature that's integrated into Lava. That's something that's written in the test definition that they do. And then, since we have a TI representative here, this was a request to have actions that repeat. So we are going to have that feature, which is something that that we don't currently have support for. So if you wanted to loop a boot test 10 times, instead of having 10 blocks of JSON that's a boot Linaro image, you can simply have a repeat action, which is then it inherits from the base action, which is repeat action, which whatever actions inside of that subset will then repeat. So Lava test shell, same way. Any of the actions can be repeatable. Okay. Slides? Okay.
How do we get the result reporting of those repeated runs? So there is like one definition, and then we have repeated a couple of times. How the reporting is done?
They will be separate actions in the pipeline. So if you specify repeat 4, you will have 4 actual actions in the pipeline when the pipeline is generated.
But when looking at the results, will I know, okay, it put it 4 times, but the 5th one failed?
Yeah, so we need unique identifiers when we do repeat actions.
The pipeline gives us unique identifiers all the way down because the structure of the pipeline gives each action a label that is unique for that job. It's not going to be the same label across jobs necessarily, but it's going to be a unique identifier for that action in that structure.
So I would be able to make a match between what I submitted for doing and what was actually done.
Yes, and that's part of the simulation. That we basically do a rehead and we build a pipeline before it's submitted, so that we know it should boot 5 times, right? And if, when it doesn't boot 5 times, we can give you that delta, saying, hey, it booted 4 times, but on the last time it failed, because we know how many times it was trying to boot. Same with the tests.
But what Lindy is saying that there will be some unique ID of each action.
Absolutely.
Yeah, that's going to be the structure within the pipeline. So if it's the 4th action, if its parent is the 4th action, it might be 4.2 or 4.2.6.4. That will be a unique identifier for that particular action, and then that will be retained through all of the actual all the exposure.
We got it. But this is a good discussion. I think we should continue this in the hacking sessions. So thanks for coming, guys. I really appreciate the input, and find us in the hacking session if we didn't address your issue. You want to talk more. Thank you.